In this section, we're going to learn how to do long division and synthetic division using polynomials. But first, let's review how we do long division with numbers. Say you want to do this. Well, 31 times 3 is very close to 94. Then you do 3 times 31, which I happen to already have. But this product goes here and you subtract. You get 1. And you can bring everything else down. Now, 31 does go into 15. Goes in 0 times. 0 times 31 is 0. And when let's just bring the 5 down. 15 minus 0 is still 15. Now you bring down the 6. And 31 times 5 is 155. 155 you subtract. Okay, I had 1 in my mind because I knew the remainder would be 1. When you subtract those two numbers, you get 1. So it's plus 1 over 31, which we normally write like that. 7 plus a half is 7 and a half. You should know how to go from 7 and a half to a sum. Okay, so quick review on long division. We subtract. Now, suppose you want to compute x cubed plus 2x squared plus 2x plus 1. You want to divide this by x plus 2. I'm going to use long division. So the denominator goes out there. Just like if you were going to do 10 over 2, you would do 2 into 10. The denominator goes outside the bar. The numerator goes inside the bar. Numerator inside the bar. Then you ask yourself, what do you multiply x by to get x cubed? That is 1 plus what gives you 3? 2. Multiply by x squared. And like always, you multiply what you put on top by what you have in front, namely x plus 2. And you get x cubed plus 2x squared. X cubed plus 2x squared. And you subtract. And by design, that's going to cancel out. Surprisingly, that cancels out too. So, you bring down everything with this. What do you multiply x by to get 2x? Positive 2. And 2 times x plus 2 is 2x plus 4. 2x plus 4. And you subtract. 2x minus 2x is 0. Don't forget to subtract. 1 minus 4 is negative 3. That's the remainder. I'll write it as minus 3 over what we are dividing by. That is long division. Now, you can check it by multiplying this by that and make sure you get that answer. Just like 2 into 10 goes 5 times, this product should equal the number under the bar. So why don't we actually try that? Let's take x plus 2 and multiply it by x squared plus 2 minus 3 over x plus 2. Let's not worry about that last term yet. X times x squared is x cubed. x times 2 is plus 2x. Positive 2 times x squared is plus 2x squared, and positive 2 times 2 is positive 4 minus. Now, it's much friendlier to multiply the whole x plus 2, not just part of it, the whole x plus 2 by that. X plus 2 times 3 over x plus 2 is just 3, because that cancels out. Minus 3. Okay, let's do a little work here. And we get x cubed plus 2x squared plus 2x plus 4 minus 3 is plus 1. Got it. We got this. I multiply these two and I got this, which was always the numerator. So you can always check your work, and you really should. Now, suppose instead of being given the problem written like that, suppose we were told that 2x plus 2x squared plus x cubed plus 1 divided by 2 plus x. And we want to do the long division. You need to write this in descending order. The power of x here is 1. And the power of x for the 2. You need to remember 2. So I want to change the way 2 looks. I want it to have x's. So it's 2 times 1. Is there a way to write 1? Nobody's going to argue that 2 is equal to 2 times 1, which is equal to 2 times 1. Well, x to the 0 is 1. So I write the x to the first, and the 2x to the 0 second. It's in descending order. 1 and 0. We need to do the same for the top. X cubed plus 2x squared plus 2x plus 1. Okay. And then we can do this. In fact, in here, if there's any terms missing, you need to fill it in. Just understand that you can always add 0. 7 plus 2 is most definitely equal to 7 plus 0 plus 2. And, 0x to the 5th is 0. 0x cubed is 0. So, if you were asked to compute x cubed plus 4x plus 1 divided by x squared plus 2. Well, actually top and bottom are in descending order of x, because there's a 1 here and a 0 here. 3, 1, 0. They kept going lower. 2, 0. Now, for the number that goes in front of the bar, it doesn't matter if you have missing terms. Ooh, just 2. But inside the bar, it does matter. You highest power is x cubed. You better have an x squared, an x, and a constant term. You have 1x cubed plus no x squares plus 4x plus 1. Now whether you write this on top or not, that's between you and your pen. It could be helpful. What do you multiply x squared by to get x cubed? The answer is x. Now we multiply x by the number in front. We get x cubed plus 2x. Get x cubed plus 2x. And we subtract. In this case, my luck is that you didn't have to put in the x squared. So what I'm going to do is I'm going to change the problem slightly. X cubed plus 4x plus 1 over x squared plus x. That's going to be the problem. Okay, sorry about that. So now, when you multiply the x by this, you'll get x cubed plus 2x squared plus 2x squared. And now it's nice. This cancels out, and we have x squares right underneath one another. 0 minus 2 is negative 2x squared plus 4x plus 1. What do you multiply x squared by to get negative 2x squared? Negative 2. Negative 2 by what's in front is negative 2x squared minus 4x. So negative 2x squared minus 4x. You subtract. These two are exactly the same. When you subtract, you find out how much bigger one value is than another. They're the same. Their difference is 0. Now, 4x and negative 4x, they're not the same. 4x minus negative 4x. You can always change subtraction to addition so long as you change the sign of the second number. So you get 8x plus 1. And since this is below a second degree, that's called the remainder. It's 8x plus 1 all over what we are dividing by. Now, let's try to do this problem again without putting in the missing term. Suppose you have x squared plus 2x, and you have x cubed plus 4x plus 1. X squared times x gives me x cubed. When you multiply, you get x cubed plus 2x squared. And you subtract. That cancels. Now it is kind of unclear, but you need to picture that 0x squared, and when you take away 2x squared, you have negative 2x squared, and you still have the 4x, and you still have the 1. You need to put this in, and I'm going to the top. It's better to put it in right in the place it should be. Now, sometimes, like my first example, sometimes you'll get, say, plus 9x. And then you say, oh, I didn't even need in this problem to put in the 9x. Sorry. The 0x squared. I didn't even need to put that in. So I'm trying my best to move that over. Plus 4x plus 1. Okay? But you see it, and then you move it over. It's hard when you don't need it, you can remove it. But when you do need it, you really want to have the x squareds right here so you can subtract other x squares. Do a number of these, you will see this. Under the bar, you put the missing terms. Suppose we have x to the 5th minus 2x cubed plus 4, and we want to divide this by x squared plus 2x plus 1. This is in descending order. You don't have to fill in missing terms, although there were none. This has x to the 5th. It has no x to the 4th. It has negative 2x cubes. It has no x squares. It has no x's. Plus 4. What do you multiply x squared by to get x to the 5th? The answer is x cubed. So we put x cubed up here without changing the color. And then you multiply. What is x cubed times x squared plus 2x plus 1? Well, it's x to the 5th plus 2x to the 4th plus x cubed. X to the 5th plus 2x to the 4th plus x cubed. Notice how they line up so nicely. This cancels. 0 minus 2 is negative 2x to the 4th. Negative 2 minus 1 is negative 3x cubed. Plus 0x squared plus 0x plus 4. What do you multiply x squared by to get negative 2x to the 4th? Well, you need the negative 2 and another x squared. And then you multiply negative 2x squared by what's in front. And you'll get negative 2x to the 4th minus 4x cubed minus 2x squared. Negative 2x to the 4th minus 4x cubed minus 2x squared. And if you subtract by design, that cancels out, and you get x cubed plus 2x squared plus 0x plus 4. You have to know how to subtract. Okay, what do you multiply x squared by to get x cubed? The answer is positive x. So we multiply positive x by what's in front, and then we subtract it off. 2x squared plus x. X cubed plus 2x squared plus 1x. And we subtract. That cancels by design. Oh, how nice. That cancels for free. 0x minus 1x is negative x plus 4, which is the same as 4 minus x. So that's the remainder. Plus, it's better to write a positive thing first, all over what's in front. And there's your answer. Now, I'll show you an easier method, but it does have some constraints to it. Suppose you have x cubed plus x squared plus x plus 1, and you want to divide this by x plus 1. Let's say x plus plus 1. To use this method, the denominator has to be in the form of x plus or minus some number. You can't have 3x, you can't have negative 3x, you can't have negative x. It has to be x plus or minus a number. And remember, that number can be 0, which, by the way, is just x. Okay. So what you do here is, in here, you just put the coefficients of the top. 1x cubed, 1x squared, 1x, and 1. Now, what makes this 0, you put in front. If x plus 1 is 0. If you add two numbers and you get 0, these two numbers just differ by signs. So x must be negative 1. And you always start off by putting 0. And then you add. 1 plus 0 is 1. You multiply and you put it up there. You add. You get 0. Negative 1 times 0 is 0. You add. Negative 1 times 1 is negative 1. You put it here and you add. That is the remainder. There is no remainder. That tells us that this answer is the following. Just give me one moment. Let me erase a lot of these arrows. What's in the bottom is the answer. It's gonna be 1x squared plus 0x's plus 1. That is x squared plus 1. This is equal to x squared plus 1. If you multiply those two, you will get what's on top. That is called synthetic division. A lot better than doing long division, but it only works if the denominator is a constant plus or minus a number. Suppose you have x to the 5th minus 1, and you want to divide this by x minus 2. What makes this 0 is the number 2. What goes under the bar is 1x to the 5th, 0x to the 4th, 0x cubed, 0x squared, 0x's, and the constant of negative 1. Always put a 0 there. And you add. You get 1, you multiply, you put the number up there. You add. 0 plus 2 is 2. You multiply, you get 4, you put it up there. Then you add 0 and 4. You multiply, you get 8, you put it there. You add, you get 8. You multiply, you put the answer there, you add. You multiply 32, you put the answer there, and when you add those two numbers, you get the remainder. And now we know that x to the 5th minus 1 over x minus 2 is 1x to the 4th plus 2x cubed plus 4x squared plus 8x plus 16 plus 3 divided by x minus 2. And you can fairly easy check it. Remember, this times that should equal the numerator. X minus 2 times x to the 4th plus 2x cubed, etc. Okay, we'll multiply those two, you get x to the fifth. Those two, you get 2x to the fourth. Those two, you get 4x cubed. These two, you get 8x squared. Plus that is 16x. Then I'll distribute the 2, negative 2. I'll put them underneath the others. Negative 2x to the fourth. Negative 4x cubed. Negative 8x squared. Negative 16x. Minus 32. Plus this times that. X minus 2 times 3 over x minus 2 is just 3. Plus 3. Uh-oh. Uh-oh. Ah. It's 31. I thought that 1 was a box. Plus 31. Plus 31. When you multiply this by this, you get 31. Minus 32 plus 31. Where did the minus 32 come from? Negative 2 times 16. Okay, but I already put it on top. Alright, now look at the magic. We're adding. This cancels the 0, this cancels the 0, 0, 0, and that's x to the fifth, and that's minus 1. We got the right answer. Okay. Now, there's some really nice things going on here. Won't prove it right now. Let your teacher prove it. But I claim that this remainder, let's give this numerator a name. This remainder is g of that. In other words, if g of x is x to the fifth minus 1, and somebody asks you to find g of 2, you put the 2 out here, 1x to the fifth, no x to the fourth, 0x cubed, 0x squared, 0x is negative 1, and you do this all over again, and you're going to get 0, 2, 4, 8, 16, 32, 31. That is g of 2. If you don't believe it, 2 to the fifth is 32 minus 1. Let's look at this a little bit more closely. Suppose I were to tell you that h of x is equal to 7x cubed minus 2x squared plus 3x. And I want you to find h of 4. Well, one way of doing it is 7 times 4 cubed minus 2 times 4 squared plus 3 times 4. Going to have heavy duty multiplication. 4 cubed is 64 minus 2 times 16 plus 3 times 4. 420, 448, I'm pretty sure. Yeah, minus 32 plus 12. This is equal to, I take away 3, and then I take away 2. plus 12. This is 428. If I didn't make a mistake. Another way of doing it is you take that number and you do synthetic division on it. 7x cubed minus 2x squared plus 3x plus 0. Put down the 0, add. 4 times 7 is 28, add. 24 times 26 is 104, add. Get 107. 4 times that is 428, and when you add 0 and 428, you get 428, which is h of 4. This is just another way of doing function evaluation. If you have g of x is 3x cubed plus 7x squared plus 2, and you want to find g of 1. Well, this is pretty easy. 1 to a power is 1, 3 times 1 is 3, 1 to any power is 1, 7 times 1 is 7, plus 2, 10 plus 2, 12. If you want to use synthetic division, you put this number in front, and then you put down all the coefficients. Coefficient of x cubed, x squared, x, and 2. Put a 0 there. Or some people would just say bring down the 3. You multiply, you put it there. You add. You multiply, you put it there. You add. You multiply, you put it here, and you add. That is g of 1. This stuff works. It's another way of doing function evaluation for polynomials. Okay, for polynomials. If f of x is 8x squared plus 9, and you want to find f for 5, which is 8 times 5 squared, you should know the value of 8 quarters is 200 plus 9, 209. Or you can do 5, 8x squared, no x's, 9. Bring down the 8, multiply, add, multiply, and then add. That is f of 5. It's a new way of doing polynomial function evaluation. Pretty neat. Okay, that completes the section on long and synthetic division.